Open-Endedness, I think, is trying to get into people's mind. It's like we have to think about approaches that can just endlessly basically self-improve and find new interesting artifacts.
To understand human-level intelligence, we are going to need to understand creativity. It's a big part of what being intelligent means from a human level, is our creative aspect.
So what we want with open-ended systems, we really care about generally capable AI. So AI that we could at some point throw at any kinds of problems, right? And would like autonomously explore, set themselves goals, figure out like solutions to things that humans haven't even thought about. We have to really get surprised in the future, right? By kind of AI discoveries.
We may need to actually implement and run some kind of creative process or open-ended process that produces this general intelligence.
So where do you see this space going in the next few years?
So I think
There's a really exciting startup called Slingshot AI, and they are revolutionizing chatbots for mental health.
I'm Daniel. I'm one of the co-founders of Slingshot AI. We're training a foundation model for psychology in partnership with amazing behavioral health organizations. We're training the first model to actually model and understand the mind, and using this to help people through their mental health journeys. If you think that you'd be a great fit for our founding team, I'd love for you to reach out. I'm Daniel C. at slingshot.xyz. We're hiring for machine learning engineers to join our founding team, especially with experience training and fine-tuning language models.
I'm Tim Rocktäschel. I'm a professor of AI at University College London, and I'm also the Open-Endedness team lead at Google DeepMind.
And you're part of this famous UCL DARK Lab.
Yeah, I'm very proud, obviously, of that lab. We started that together with Edward Gravenstedt in, I think, 2018 or so. And we had a lot of amazing PhD students doing research with us, Minchi Jiang, and there's a number of them graduating this year and next year as well.
Yeah, I'm working my way around them. So I did Akbir this week. I've had Laura on. I've done Minchi. I've had Ed Gravenstedt on, of course. So it's like a pocket of greatness in the UK.
Oh, thanks so much.
Yeah, and of course you and Ed are now at Google DeepMind.
Yep, that's correct. Yeah.
What do you do at DeepMind?
So at DeepMind, we are, I guess, doing two things. One, we're looking into training foundational world models from videos. We had a paper here at ICML called Genie, Generative Interactive Environments. And the other thing we do is we look a lot into self-improvement with large language models. So we're also presenting a paper called Prompt Breeder, Self-Referential Self-Improvement. So basically, trying to see how we can get these foundation models to improve, to be more agentic, to autonomously, find diverse solutions to problems.
Yeah, I mean, maybe we should touch on Prompt Breeder, but more broadly, though, I mean, even the name Prompt Breeder came from Pick Breeder from Kenneth Stanley.
Yeah.
And, I am Kenneth's biggest fan. I mean, our special edition on Why Greatness Cannot Be Planned a few years ago is my favorite ever episode of MLST. Everyone should read his book.
Absolutely, yeah.
And, you're in this space as well. So what does open-endedness mean to you?
So, first of all, I fully agree, the work that Ken Stanley, people like Joel Lehman, Jeff Clune have been doing, I think that was hugely inspirational for, a lot of researchers, including myself and PhD students in my group. We, maybe to just, track back a bit, I was doing reinforcement learning research for probably 6 years or so, or 7 years. One of the things that we felt was missing in the field is finding approaches to problems where you don't have a reward function, right? There's these kind of position papers on reward is enough, and that all makes sense. But, for most interesting real-world problems, there's just nobody giving you this kind of reward function, right? You can do amazing self-improvement, self-play techniques for something like Go and chess. For other problems like StarCraft, maybe you have a lot of human data you can train on. But ultimately, you want AI that can, be thrown into environments and problems where they just have to discover by themselves what are possibilities, right, and what are potential solutions. So in, I think it was around 2020, we released this environment called NetHack, the NetHack learning environment. This is just maybe briefly, is a game from the 1980s. That is procedurally generated and immensely complex. You can think of it a bit like a Minecraft, but played in a terminal. So everything looks quite arcane. You have these kind of ASCII characters and so on. And if you play a game like this, there's really just not much kind of guiding reward, right? You are going to just experiment. You're going to try over time through many trial and error episodes. You're going to investigate and you're going to figure out some stuff about the environment dynamics. So we looked a lot into, at the time, intrinsic motivation techniques for reinforcement learning agents and so on. And it was around that time, I think it was Minchi who read, Ken Stanley's book and Joel Lehman's book first, and then said, look, we really have to, everybody should read this. So, I read this as well. And it was like, yes, I think it's this kind of quest for open-ended methods, right? For open-ended learning approaches where there's not necessarily a specific objective function we are optimizing for, but instead we want to find this kind of diversity of solutions that then become stepping stones for other solutions. And we just want to be able to run this for a long time and see what happens. And I think it's really interesting if you think about like all the like work that's happening in AI right now. I don't know of any like approach, any method that would be worth to run for, let's say, longer than a few months, right? Even if you think about, Gemini or ChatGPT, when these kind of foundation models are trained, like nobody would train that for a year or 2 years and 3 years, and then just, it would be constantly new, exciting things happening, right? Like at some point you just train on that static data set and you're done. And what open-endedness, I think, is trying to get into people's mind is like we have to think about approaches that can just endlessly basically self-improve and find new interesting artifacts.
Yeah, it mixes together so many interesting ideas in philosophy as well. And we'll get onto your position paper in a little bit where you try and formally define some of this. But I've got Kenneth's words ringing in my ear right now. So he was talking about evolution, and he said evolution, it just goes on and it just keeps accumulating information, and there's just new novelty and niche construction, and it just goes on and on and on. Whereas you train something like a language model and it converges, and then that's it. It's the end.
Yep.
And all of these operative words come out when we're talking about this. So things like creativity, novelty, serendipity, subjectivity, agency. And what we're trying to do with these words is we're stabbing in the dark a little bit. We're trying to get a handle on what this thing is. I mean, what is open-endedness to you?
I think what Ken Stanley often does is like pointing to like these kind of existing systems that I think all of us would classify as open-ended, right? There's biological evolution, and then you could also talk about technological evolution, cultural evolution, and so on. And what we tried in my team last year, and obviously this is hugely influenced by a lot of the work that happened before by Ken Stanley, Joel Lehman, Jeff Clune, Minchi Zhang as well, is to actually try to come up with a formal definition. And also that has been tried multiple times, right? I think there's right now still, I guess, an ongoing debate about what's the best way to kind of formally define this. But it is, to us, it's a combination of a system that produces artifacts over time, and that these artifacts for an external observer would be both novel and learnable. So why is learnable important? So imagine you have a noisy TV, right? That just every frame is going to look novel because it's going to be just random noise. That itself is not an open-ended system, and according to our definition, for any like sensible observer, but because the observer wouldn't be able over time to make any sense, right? Because there's no underlying structure to learn. Whereas if you think about like biological evolution or technological evolution, as you observe the artifacts coming out of that system, right, you see, you can learn about certain like structures, right? You can learn about certain progression of artifacts. You would be able to, predict, or not predict, but you would, the next, artifact you find, you would be able to put that into context and relationship to all the artifacts you've seen before, right? If there's a new frog that evolves, right, you would be able to make sense of that in the lineage of all frogs and animals coming before that, right? Whereas with a noisy TV, there's just no chance. So that's why learnable is important. And well, the other one is novelty, right? Because if you have something that's learnable for you, let's say coins, right, in the European Union, right? You look at those, you see them like from the different countries, and you kind of learn about like how each coin for each country looks like. At some point, you've seen them all, so you have learned. But at some point, there's obviously no novelty anymore. So we wouldn't call that an open-ended system for any sensible observer either. And then the observer is really important. This argument was made, I think, before as well. The observer is really important because there's basically no objective way to, I think, measure open-endedness. Think about, for example, Go, right? AlphaGo. So you have this system that learns through self-play to get better and better at Go. And at some point, it becomes even better than any human on Earth on Go. So for a human observer, right, for a long time, this system produces both novel behaviors and also learnable behaviors, because you, as a Go player, right, you could start to kind of learn from these behaviors. But at some point, it's kind of transcending what any human can do. And there's basically a region, right, where this kind of AlphaGo, it plays so superhuman Go that no Go player on Earth can really necessarily differentiate between, let's say, an AlphaGo that has an ELO of this and an AlphaGo that has an ELO of that, right? So within that kind of context, it's not really an open-ended system for a human observer, because the human observer can't follow the progress anymore. But in this kind of period until there, right, there's a lot of like both novelty and learnability for humans.
Yeah, I don't know if you're familiar with Stephen Wolfram's observer theory, but there's hallmarks of that. He says we're computationally bounded as observers.
Yep.
And that's, kind of what you're saying, that, beyond a certain cone of intelligibility, we're not actually able to tell if something is open-ended anymore.
Exactly, yeah.
But on this interestingness, so Kenneth used the word interestingness. So he said like a completely divergent open-ended system would be useless because it would just be doing random things. And so there's this operative word interestingness, but it's so difficult to define. And you commented in the paper that your definition makes no explicit mention of interestingness. More precisely, interestingness is represented in our definition by the observer's choice of loss function L. So I'm thinking there that isn't that kind of like saying, well, it depends on what the observer chooses. Like how is that actionable? So, for example, the observer might choose the loss function of coins. You were talking about coins. So coins are learnable to that particular observer, so they choose that particular loss function. But I guess my intuition is like, if learnability is dependent on the choices made by the observer, doesn't that in some way degrade the formalism?
I mean, I think it just emphasizes how subjective this is, right? Like I might be, for example, super interested in coins, of like medieval coins, right? And so I get really excited about like looking at all of these and learning something about them. But a different observer, even a different human, right? For them, I get another like medieval coin. I don't care to like even differentiate between like different medieval coins, right? So they, in terms of their, they wouldn't even like learn basically about like these kind of artifacts going forward. So there would not necessarily be any interestingness, right, for that observer in kind of seeing more and more coins, right? But for maybe someone else it is, right? So I think it just underlines how subjective this is. And I think us as open-ended as researchers, we just have to embrace that that's what it is. It is subjective.
I actually really like that you came up with this notion of learnability. And I think of it as intelligibility, right? But then are there examples of things which are intelligible but not interesting?
I could imagine. I could imagine. So, I mean, again, I think it's extremely subjective, right? I mean, somebody looking at I guess a noisy TV is an extreme example, which probably for anyone isn't interesting, right? But then you could imagine, I don't know, soap operas. I might not find that interesting, right? So for me, that's like maybe similar to a noisy TV. Like I just my brain just shuts off when I see that, right? And then I think it's going to be a massive spectrum that depending on who you ask, right, they might find certain things in there interesting or not interesting. And again, that's just, I think, the world we're living in, and I think we have to take that into account when we're trying to create open-ended systems.
Yeah, I mean, I'm going to show the figure on the screen now, the one with the artifacts and the observer and the novelty and the learnability. Yeah. Can you just talk us through that?
Yeah, of course. So this, comes back to this notion that open-endedness is subjective. So if you had a observer that, for example, I think the example we give, it's like a mouse or so, right? Like the mouse looks at, let's say, the papers coming out of archive, right? And for the mouse, like none of that makes sense. So it's not going to be learnable, but it might be novel, right? Like it might like be able to see that each of these kind of papers is novel, but it's because it hasn't seen that before, but there's nothing to learn. So therefore, for like that mouse, it wouldn't be an open-ended system. Now, for some like really superhuman entity, so you could think of like, let's say, a superhuman AI, or I think the example we gave in the paper is like some kind of alien visiting Earth, and then now let's say also is looking at the stream of archive papers. Maybe they've already like discovered all of this, right? Like maybe they're like 10 million years in the future in terms of technological advancements. So they look at all of these papers, and for that alien, right? It's like learnable, or it has already been learning basically about all these things. So it's not going to be novel, right? Or interesting in this case. And then there's this kind of sweet spot, right? Where you have, let's say, human observer looking at the stream of archive papers, and for that human observer, it might be both learnable and novel. And then for that human observer, like the stream of archive papers would be like an open-ended system. But I think that what's really interesting, I think you touched upon this earlier already, we humans are obviously bound, right, in terms of how much information we can take in. Like for me, archive is absolutely overwhelming in terms of the number of papers that come out. And also, obviously, my time on this earth is bounded, right? So one concrete example that we give in the paper is we had this other paper called Human Timescale Adaptation. So it's using this vast space of 25 billion procedurally generated environments, and then training a basically in-context learning reinforcement learning agent inside of these environments to do autonomous hypothesis testing. And we can show really amazing out-of-distribution generalization within this kind of space of these kind of billions of procedurally generated tasks. So if you train this system, if you run the system for a few months, right, you will see more and more capabilities emerging, and you would, in the context of these 3 months, you would call this an open-ended system. But if you actually then run it for, let's say, 3 months longer, I think we will all look at this and we would see somehow, novelty basically degrading. So I think, we alluded to this a little bit in the position paper. I think it's also always the question of like, what's the kind of time scale you are looking into, right, for a system.
Yeah, and just to reiterate, so your definition was, from the perspective of an observer, a system is open-ended if and only if the sequence of artifacts it produces is both novel and learnable. And so you did actually give a few interesting examples. Poet was one of the first papers that we ever did on MLST, and that was, it was from Kenneth Stanley, where you kind of like have a population of environments and agents, and you swap the agents between the environments. And he was trying to make it as divergent as possible, because he said that systems converge really, really quickly, and if we can make systems continue to accumulate information, then it's a divergent system. But even Poet, still converged eventually. Yep. But the reason I said your definition is it was quite carefully crafted to be not anthropocentric and to not focus on things like evolution, and it could encompass like discussions about language models or things like AlphaGo. And I want to touch on AlphaGo in particular, because this is something that I wouldn't think of that as an open-ended system. What do you think?
I think it has a lot of fantastic ingredients that would believe us to call this an open-ended system, right? I mean, there's this kind of amazing self-play component, right? So you have the system just playing against itself over time, many millions of iterations, basically learning at some point, like strategies that humans didn't even know existed, right? And we've been playing Go as humans for like thousands of years, right? So to us, this kind of move 37 from AlphaGo, I mean, it's such an amazing example of what ultimately open-ended systems are going to be able to do. They're going to be able to show to us, right, really novel discoveries. So from that point of view, right, you would call this an open-ended system. But if you try to then apply this, I think, definition more strictly, right, you would again say, well, it is observer dependent. And I think it's fair to say at this point that AlphaGo, AlphaZero is it's better than any human on Earth, right, in playing Go. So there's a certain, as I mentioned earlier, there's a certain threshold above which no human observer, I think, will be able to differentiate between, like, let's say, novel artifacts. And artifacts here would be novel Go policies, right? We're just not able to do this anymore, right? We can let these things play against each other, and then we can, calculate some kind of ELO ranking, and we could, like, from that perspective say, okay, this, let's say, AlphaZero system that has been trained longer is maybe better than that other AlphaZero system. But in terms of actually assessing the novelty of these kind of artifacts and the learnability, like, we can't really learn anything from that anymore, right? We can't, like, imitate that kind of behavior anymore. We see right now, I think, lots of professional Go players using, obviously, systems like that, right, to explore new Go strategies and learning from that. Like, we see that, but that's basically, I think, it's basically catching up right over here, whereas AlphaZero, in terms of its superhuman capabilities, probably somewhere up there, right? And the gap's just going to widen more, and we're not going to catch up, I think, quickly enough to ever become as good as AlphaZero, right, as humans.
Can we explore the Go skill thing? So yeah, there's a huge dynamic range of skill, like ridiculous, and it's almost like a hotel where you've got all of these different floors where, one floor above you beat the guy in the floor below or whatever. But humans are very creative. And the skill of Go, you might argue, is a narrow form of skill. It's constrained in lots of ways by the predictive architecture. So we have stronger creativity. So we might be able to do some epistemic foraging. We might be able to discover some knowledge which defeats AlphaGo. And then AlphaGo would no longer be seen as better than us. Like, do you think that could happen in principle?
So I think what can happen in principle is AlphaGo being still driven obviously by a deep learning system, right? You as a human, being the creative being you are, might come up with some kind of adversarial attack to AlphaGo, like something really out of distribution to get it into some kind of range in the representational space where it just like starts to screw up. And I think there was even papers that show that in principle is possible with some kind of I think like some kind of ladder attacks also. I think Michael Dennis from my team had a paper on that, if I'm not mistaken. So I think that I can imagine, right? But I think it's still clear that this kind of self-play approach, it can just like illuminate a certain behavioral space that for humans in their lifetime is just impossible to replicate, I think. And with that, I think it is fair to call this an open-ended system in the context of Go. But one of the things that I really strongly believe in, and I think it's fair to say, is that there's no way we can take a system that's trained in Go and then, for example, take that policy, take that neural network out of that, and then expect that to do anything sensible in other domains, right? So what we want with open-ended systems, at least in my team, right, we really care about generally capable AI. So AI that we could at some point throw at any kinds of problems, right? And would like autonomously explore, set themselves goals, figure out like solutions to things that humans haven't even thought about. We have to really get surprised in the future, right, by kind of AI discoveries. And I think there's just no way that you can get that by training inside of a environment like Go or chess or even Minecraft, and then hope you can like transfer that to all kinds of other problems, right? So there was a really good paper also presented here at ICML from DeepMind on the levels of AGI, and the kind of separation that they make is, well, we can talk about obviously narrow domains, and there we're basically at superhuman level, right? So level 5 in their kind of AGI spectrum. So it means a thing like AlphaGo is better than any human on Earth, right? But then what we really care about, I think at least nowadays, more and more, is like more general AI, right? And there they argue we're currently at the kind of emerging AGI stage with things like Gemini and ChatGPT. And the question now is like, how do we close this gap to artificial superhuman intelligence? And the paper that we presented here on open-endedness is essential for artificial superhuman intelligence, is referencing obviously that kind of spectrum of levels of AGI.
I love the terminology you just used, like the behavioral space. I think that's a great way to think about it because, let's say that a human did come up with some creative adversarial attack and they beat Go. It still wouldn't have the same, behavioral space complexity. But I just wonder, how would you interpret that? Would you interpret that as the human beating the AI, or would you still think that was some kind of a glitch and it was not in the spirit of the intelligence?
No, I think it's fair, right? Like we humans are, as you said, we're extremely creative and we're also extremely robust, right? So I imagine if you're like Lee Sedol, like you're one of the best players in Go in the world, you're not going to be falling trapped to like some like really really constructed, very adversarial attack, right? Because you are just so much more robust in terms of your capabilities. Yeah. So I think it's fair game, right? If a human finds a reproducible, let's say, adversarial attack to something like AlphaGo, then I'll be very impressed, right? And I could imagine that's possible, right? But then it's also clear that I think there's quite easy ways to then feed that back into the AI training loop and let that model become more robust against these kind of attacks. And I think there's a nice connection to what's happening now with these large language models and foundation models in general, right? So there's ways to jailbreak these systems. You can do some role playing with these LLMs. You can try to introduce some kind of misspellings, and suddenly they are very happy to tell you about all kinds of unsafe things. And I had a I have a PhD student, Mikael Samvejan, who has done a really amazing paper called Rainbow Teaming, which takes inspiration from open-endedness research and tries to apply that to make these kind of LLMs safer. And the thing that he's doing is basically he lets the LLM itself generate adversarial attacks against itself. So it's this kind of self-play component. And he's doing that in a way by using the LLM to mutate existing attacks that work well to find other novel attacks. So it's kind of really this open-endedness idea of like finding stepping stones that can lead to other stepping stones that can lead to even stronger attacks by combining also like different previously discovered attacks. And he's also taking inspiration from these kind of quality diversity approaches where you at the same time looking for these kind of really powerful attacks and you try to keep a diversity of like different attack styles. And that works extremely well, right? So the LM is discovering extremely quickly, hundreds of thousands of like jailbreaks for itself, and then you can use all of that data, the synthetically generated data, to make the LM again robust to all of these attacks. And I could imagine we could try out similar things for something like Go, but in some way that's happening already for this kind of self-play approach.
Yeah, it might be worth lingering on this stepping stone collection. So in Kenneth's book, he spoke about the false compass and stepping stone collection, and he gave the example of if you want to be a billionaire, the worst thing you can do is go and get like a salaried job. The path to greatness is always unknown and it's serendipitous. And then there's the paradox of interestingness. So it has to be divergent, and the more you try and impose your will on it, the less likely you are to get it.
Yeah. 100%. Like, and I think it's important to dwell on like how profound this is, right? Not just for like building, let's say, AI systems, self-improving, open-ended AI systems, but even for your like own research or your own career. Like, just to give you one concrete example. So since reading this kind of book, I am trying to make sure that in our group at UCL DARK, but also in my team at Google DeepMind, we don't really optimize for conference papers. Right, so what we do is we're trying to think about, okay, what in our view might be the most exciting thing we could be doing over the next like year or two, and then you can try to be very concrete in terms of, okay, this is the kind of North Star we want to achieve, right? But you just have to embrace that as you then do the research and you chop this down into different milestones and you think about, okay, if we want to be there in 2 years, what do we have to do by next year, next half year, next month? And then as you start embarking on the research for next month and you get the actual empirical evidence, right, obviously things are changing, right? You're actually then realizing you're maybe moving a little bit more to the right, and you have to adjust and so on. But what's really important, I think, to us was to not think about, okay, there's now, I don't know, the next conference deadline, so let's think about, okay, what is the paper we could like get ready for this kind of conference deadline, right? We think more about like, okay, what's just exciting research? And then over the course of a year or 1.5 years, we got papers like, Genie, Generative Interactive Environments, or the AI debate paper. And now both of them won the best paper award at ICML, and we didn't optimize for this, obviously, right? We optimized for good research. So I feel like you can take these kind of concepts from open-endedness, the things that Ken Stanley and Joel Lehman talk about, and really try to apply that like more broadly to almost everything you do.
Yeah, and by the way, congratulations, 2 best paper awards at ICML. That's absolutely insane.
Yeah, it's fantastic. But again, like we didn't optimize for it, so it's basically these things that then good things happen, right? Greatness happens.
Yeah, I mean, something that I asked Joel Lemon about, one of the co-authors of Why Greatness Cannot Be Planned, is holding the 2 ideas in your mind at the same time. Because I spoke with someone who's doing Zen Buddhism the other day, and serendipity is great. It's a great way. It's a great philosophy to live your life. But we also work in the real world, and there are objectives, and there are various forms of alignment. We need to align with each other in order to work well together. We have to set plans. How do you how do you close those 2 worlds together?
Yeah, it's a fantastic question. So, I mean, first of all, on a high level, I think one thing that's really important is to, for example, embrace foundational research, right? So we are now in an age where we see tremendous successes with generative AI and large language models and generative video models and so on. And I think it's beautiful to see, right? Like, I'm very excited about this. Like, works like Genie are an example of like trying to progress in that space as well. But I think it's important to just stay humble and realize like there might be all kinds of other approaches, right, that might take over even paradigms like this, right? Or maybe there's really very creative new things that we have to invent, right, to make these systems actually intelligent, right, and move again further up into these kind of levels of artificial supreme intelligence. So I think it's keeping around this kind of diversity. Having seen this at Google DeepMind, I think it's really fantastic to see that we're kind of taking a bet on like generative AI and building Gemini and next versions of that, of course, but also we have really fantastic teams trying to think a little bit outside the box and also have a bit more of a long-term kind of view. And that's, for example, my team. We're in foundation research. But then if you zoom in, I think in terms of the day-to-day research, for example, one of the things that I do is I keep a pretty comprehensive kind of graph, basically, of notes. There's a fantastic book called How to Take Smart Notes by Sönke Ahrens. And if you have read Greatness, Why Greatness Cannot Be Planned, and you read this book on like taking smart notes, you put this together, you just see a lot of these kind of connections in terms of how do you set up a system that allows for these kind of spontaneous discoveries. So what Sönke Ahrens is arguing for is basically to take a kind of slip box approach where you take notes and you start to basically as you develop your thoughts and as you read, let's say, papers, right, you kind of add more and more notes to this kind of system. But the system isn't like rigid like a mind map where there's only like these kind of few paths along, right? But there's actually something where it's more like a graph where you can then basically find connections between some of the thoughts that you had before that you weren't even aware there might be a connection, right? So it's kind of embracing again this kind of idea of stepping stones and trying to apply that in many like areas of my work. That's at least how I'm going about it.
Yeah, and are you a fan of like local serendipity or global serendipity? Which is to say, like you could have local serendipity and global organization or vice versa.
Yeah, so I think I care about, absolutely. Yeah. So coming back to your original question as well, I think as you kind of embark on like this kind of open-ended search for stepping stones, in my case, towards general intelligence, obviously for teams, there needs to be some kind of alignment in terms of what we're trying to achieve, right? So when we come together as a team, for example, for this Genie paper, we have a certain intuition or belief about what might be possible in 1 or 2 years. And we all get excited about this, right? And we believe like, if we can scale these things up, who knows, right? We might get really fantastic, visually rich, generative worlds, right? So that is the kind of, almost like the kind of mission maybe that we, let's say, subscribe to in terms of a project team like this. But then in terms of how we actually progress in this research, let's say day to day, week to week, we just have to embrace that there might be many paths towards that, right? And also as we embark on it, as new empirical evidence comes in, we should obviously be open to like change our minds in some way and like readjust the North Star a little bit, right? I feel like that is really this kind of tension between long-term, vision and more like short-term, mid-term, open-end exploration. Like getting that kind of right, I think is to me really important. And I'm really lucky to work with a lot of amazing people who kind of subscribe to that to some extent.
I think there's a relationship between open-endedness, creativity, and agency, and I certainly explored that a lot in my last conversation with Kenneth. And by the way, Demis Hassabis did a talk recently, and he was talking about the ladder of creativity. So there's like kind of combinatorial is the second one, and inventive is level 3. And Margaret Bowden has spoken about something similar. And I actually interpreted your definition of open-endedness as, and because I've been trying to define creativity myself, and I would almost call it a definition of creativity, which I think is fascinating. But just to close off the question, though, you're talking about how this could be combined with language models. So language models are trained on static data sets, and you said they're really good for guiding the search space, and open-endedness is for uncovering new knowledge. So we're talking about reasoning, we're talking about open-endedness. It's all about being able to create something new, which is outside of what we already know.
I mean, just to give that kind of context, I think it's fair to say that open-endedness for many years has been somewhat niche, right? Like when Ken Stanley, Joel Lehman, they did Big Reader, and I'm not sure if Joel Lehman was on this, but anyway, it was somewhat niche. Even when Jeff Clune and others did Poet, and when we did a lot of like automated curriculum learning and evolution for environment design and so on, I think open-endedness wasn't yet really seen as one of the maybe driving forces towards getting to a more generally capable AI. And that really has changed, I think, in the last 2 years since large language models became mainstream and so successful. And I think there's 2 reasons for this. One is one is the reason that we see maybe more now, which is it doesn't seem like we can just scale up these large language models and they will just keep on providing, amazing capabilities. I mean, there's probably still some room for that, but I don't think, at least I personally don't believe that by just training on more static data sets at some point, we get like really capable agents emerging from that. I mean, these LLMs are used in all kinds of places right now as agents, but I think people see right now empirically how that has like limits, right? So that is one. I think we start to realize that we need things like self-improvement, autonomy, agency, somehow being built right on top maybe of these foundation models. And there's great examples like, for example, NVIDIA's Voyager paper, right? How you can use an LM to then build a Minecraft playing agent around it. So this is one. The other one is when we do open-endedness research, I think for us, for a long time, it was quite difficult to think about how to basically navigate these horrendously humongous search spaces. So even if you just take a search space like, all kinds of RL environments you could be coding up in Mojoku, right? It's an explosion of possibilities, and it's not really clear how to navigate the space, because if you just have some kind of evolutionary approach within that search space, then you can run into all kinds of niches, but it becomes impossible to kind of explore a sufficient diversity of those just computationally, right? Whereas in biological evolution, I think the thing to really realize is I think the way I phrase this is that biological evolution is basically the compute multiplying chain reaction of the universe, right? With every time you have biological evolution discovering new niches and organisms kind of proliferating in those, they also, like, compute increases as well, right? Whereas with our systems right now, we're bound by the actual, let's say, GPU or TPU compute that we have. So it's very different to biological evolution in that sense. But these search spaces are humongous, and if we want to find ways to kind of efficiently navigate those, we need some kind of prior about what should be interesting, right? And Jeff Clune's lab has done really exciting work in this space. They had this Omni paper and now Omni Epic paper, where they basically show that because these foundation models, like large language models, have been trained on so vast human textual data sets, they also learn implicitly basically the notion of interestingness, because people write about what they find interesting, among other things, right? So you can actually use these LMs to automatically assess what's interesting. And that's mind-blowing, I think. And if you combine that then with also the other observation that you can use these foundation models as a mutation operator to vary data, and then you bring these two things together, you just suddenly have something that can mutate, create variations, and can select. And there you go, then you have a potentially quite powerful evolutionary approach.
Yeah, I mean, I was talking to a program synthesis guy yesterday, and we need to do verification, but LLMs are great for cutting down the search space. And you made that assertion in the paper that because the LLM is trained on all of the data we've produced, they have an implicit notion of what we find interesting. And then there's the alignment thing as well, because you were saying before, an open-ended system should be learnable, it should be intelligible to us, so it should produce stuff that we understand and we're interested in. So this is a great way to kind of carve out the search space.
Yeah, but then I think the next frontier is going to be, if we have exhausted that kind of recipe, what you really want is similar to what happened with AlphaGo, at least the first version, and then also AlphaStar. You start biasing the system on human expertise, right? So I think both the first version of AlphaGo as well as AlphaStar have been basically trained from human demonstrations. But then you want to keep the system running to discover new things that humans have no idea about. Right, and how to kind of get that transition, that's, I think, something that's unclear, I think, to us at this point. I think that's going to be very exciting paradigm shift at some point. I don't know how this is going to play out.
Yeah, because you wrote in this paper about how language model systems could be made open-endedness. I mean, indeed, because of this kind of Wolfram style effect, we don't have a very good memory. And from the perspective of an observer, you'd be forgiven for thinking that they are open-ended in some way, because they know so much stuff. But how could we combine an open-ended framework with a language model in a reasonable way?
So I think what thing that's exciting to me at this point is, and we've been exploring this a little bit in Prompt Reader, it's the fact that you could have these LMs generate mutations. You can have these LMs automatically judging new artifacts that they build and see them through the lens of like what humans might find interesting, as with Jeff Clune's work on Omni. But also at the same time, there's a really exciting progression is these LMs start to have larger and larger context windows, right? So maybe I think a year or 2 years ago, maybe 8,000 tokens was long context that you can condition these models on. But nowadays it's literally millions of tokens, right? So you can feed entire books into the context of such an LM, or like entire, let's say, large sets of archive papers, and then you can do something with that, right? And when that happens, just imagine now this kind of mutation of prompts plus selection of prompts is now guided by everything that's coming up in archive, or like certain books on certain mental models or certain topics in maths and so on. Suddenly, I think you can potentially design quite powerful systems.
So at the moment, the AI systems we create, they're human parasitic in the sense that we supervise them and their results need to be intelligible to us, so there's a kind of symbiotic relationship.
Right.
And as we start to create agential open-ended systems, I guess there's two questions, would it work? Would they be agential in principle? And what would that interface look like between us and an ASI?
Yeah, fantastic question. So, one answer to this question is, one of the papers we're presenting here on AI debate. So that's Akbir Khan's work of like how do we get to align with superhuman AI systems. And one thing that we found is that debate is a really good protocol for that, because if you're a human and you have a question, let's say, and you consult an AI, and you can't really trust that AI to really give you the right answer, you can consult it. You can have multiple interactions and chat with that system, and at the end of the day you're going to be informed in some way. It turns out that is not the best protocol. A better protocol is to have that AI be cloned and then have that AI do a debate basically with itself, arguing for multiple answers. It turns out that that's a much better truth-seeking process. And really interestingly, we find that as these AIs become more persuasive, it's actually becoming more of a truth-seeking process, because really empirically we can see with these AIs it's easier to argue for the truth than for not the truth. So I feel like it gives us some hope that debate might be at least one piece of the puzzle to alignment. The other thing I would say, and this is, take this with a huge grain of salt, it's just my hunch right now, is there's a really fantastic book called The Beginning of Infinity by David Deutsch. Lots of people in my team have read it many years ago, and one of the things that David Deutsch is arguing for is that what scientific progress really is finding good explanations that are hard to vary, and that obviously somehow kind of align with your empirical observations. And my hunch at this point is that we're basically, when we're thinking about AI safety of LLMs, we often have this kind of this kind of fear that at some point LLMs or AI is going to create knowledge that we just can't follow anymore because it's not intelligible to us. But I think probably the most viable path towards artificial superhuman intelligence is have these AIs also strive for good explanations. And I think those are actually going to be quite intelligible for us, and we'll be able to follow that for a long time.
Yeah. The Beginning of Infinity has come up in 3 of my interviews this week, so folks at home should definitely read that. It's very important, and I will try and interview Deutsch very, very soon. It's interesting, you spoke about this potential model collapse, when LLMs start eating their own poop and we get this kind of reflexive system, but that's not really the way you see it, is it?
I think there's multiple works that came out. I think one Nature paper just today, actually, with a front cover of AI feeding on its own data. It's going to just produce garbage. I think that has. I haven't read that Nature paper, to be fair, right? So, but I imagine the argument goes something like this: we have now these chatbots online. People are using them all over the place. They also use them to populate again web pages on the web. And then as we collect again new static data sets from the web, we're going to continue to train on it. There's some kind of loop that turns these models into more and more garbage. I can see that argument, but that's not the kind of self-improvement loops that we're talking about, right? We're talking about AI not just being spoon-fed like static data sets. We're talking about AI proactively, for example, going out and seek the kind of data they are interested about learning, right? Right now, again, we train these systems, or I think most companies train these systems by feeding it static data sets, and there's going to be a lot of really high quality information in there, right, from books and so on. But I couldn't imagine a future where AI is, after it has gone through this pre-training phase, then goes into some really active, more agentic phase where it like says, okay, I haven't read all of the stuff on the internet. Let me now again, let's say read Why Greatness Cannot Plant, or read the book on, the beginning of infinity, and try to actually form a somewhat consistent model of the world. Because right now these LLMs don't have that, right? They, you prompt them in a certain way and they pretend to just play different roles. They don't have like a consistent view on, like, for example, issues like AI safety, right? Won't like tell you something consistent about it. You can prompt it to tell you anything about it, basically.
I wonder, in your own articulation, what would it mean for a system to become agentic?
I think it has to, first of all, interact with an environment, right? So that kind of means we have to go away from feeding it static data sets. There needs to be some kind of environment in which you allow that system to explore and experiment. That can be, simulated environments, could be in robotics, real environments, could be letting this thing loose on the web. And obviously there's a lot of like AI safety concerns with that. So I want to acknowledge that, right? It's not as easy as I just say. But yeah, once you allow that system to learn from its own experience online, and you allow that system to set itself goals, or at least given an overarching goal, decompose that into sub-goals that it can set and follow itself, then you start to turn that into an agent, right? And it's not just a large language model at that point.
Interesting. So kind of like intentionality basically can set its own goals, and it does what it wants to do.
And I think quite importantly, and this also comes back to David Deutsch, is like, what's the source of empirical evidence, right? And then learning from that, refining your own, hypotheses and thinking based on that kind of empirical evidence that comes in.
Very cool. Would you mind introducing your pick breeder paper? Sorry, not pick breeder. Would you mind introducing your prompt breeder paper? Because that was very interesting.
Yeah, of course. I mean, the mistake I think is almost like intentional. I think it's really building upon things like pick breeder. So maybe we should just quickly talk about pick breeder, and then prompt breeder makes more sense.
Yeah, that's a good idea. Yeah.
So pick breeder, I think it's from 2006 or 8. Is a paper by Ken Stanley's team. And what they did was, I think, really beautiful. They have this website where you can basically go on this website, and it shows you basically generated images, but not like the current contemporary AI generated images, but some things that look basically like different ways of noise. And you can select one, and it would generate mutations of that image, and you can select one, and it generates mutations and so on. And what they found is that over multiple interactions with humans, you can breed really amazing looking images, like things that look like a skull or like a butterfly or like a car, right? Because, people select basically things they find interesting, and then, you generate really, really amazing images. And the thing that they found, and this is really such a fantastic example of an open-ended system, is that let's say you started this process just by yourself and you wanted to create an image of a skull. There's basically no way for you to optimize for that. So you just have to embark on this journey, see what kind of things you discover, right? And the other thing they observed is that on the path from this, let's say, more like random looking image to a skull, there's a lot of stepping stones that don't look anything like the skull. And you can find obviously examples in biological evolution as well where that is the case, right? Where if you wanted to optimize for intelligence, you have to go through so many hoops, at least in terms of the evolution of human intelligence. You would just never select these things, right? So the connection to prompt breeder is the following. So in prompt breeder, we saw a lot of interesting work on prompting large language models. There's chain of thought prompting is a really interesting paper where you can basically show that the behavior of a large language model can be changed quite dramatically depending on how you prompt it. And concretely, what they did in chain of thought prompting is they basically give the large language model, for example, some math word problem. And if you just let the large language model try to answer that math word problem, it would basically oftentimes fail. But if you actually tell the large language model to think step by step, to basically prompt it to decompose the problem, suddenly it starts to be able to do some of these things. And they have a few more intricate processes where they also few shot prompt it with some kind of reasoning paths. But in the kind of zero shot prompting case, zero shot chain of thought prompting case, they literally just prompt it with let's think step by step. So if you now trying to change the behavior of a large language model, you basically change the prompt. And that has a really interesting connection to what Jürgen Schmidhuber was doing in the 90s on self-improvement. So at the time, he would say the programming of a neural network is its weights. So if you want to change the behavior of a neural network, you change its weights. And if you want to do that in a so-called self-referential way, so allow the neural network change its own behavior, you have to introduce a self-referential weight matrix. So you have to let the neural network change its own weights, basically. And if you now translate that into the world we're living in right now with large language models, I think the analogy you can make is that the programming of a large language model is its weights. Sure, you can change the weights and the LLM will behave differently. But because these LLMs now also quite good at understanding language, you can also change the behavior of an LLM by just changing the prompts. So if you want to have a self-referential, self-improving system, what you need to do is you need to let the LLM improve its own prompts. And that's what we did with Prompt Reader. And the way this works is we have I think we have 8 or 9, standard benchmarks for reasoning, common sense question answering, and so on. So we have these different kind of problem domains. And you let Prompt Reader try to find better prompt strategies for a certain domain by letting this Prompt Reader system talk to itself. Right, so it would start with something like, let's think step by step. It would empirically try out how well, when it's conditioning on let's think step by step, how well it would improve mathematical reasoning. And then it would mutate this let's think step by step, right, by saying, oh, how could I rephrase let's think step by step? Well, maybe I could rephrase it as, let me try to decompose the problem into blah, 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 right? And then it takes this new evolved prompt and again empirically tries out how well that works in terms of improving its own mathematical reasoning capabilities. And then you basically select, for the population, you select those prompts that have the highest fitness, meaning leading to the best kind of gains empirically when trying to do these reasoning tasks. And over multiple, generations of evolution, so variation of these prompts and selection, you start to evolve very capable prompts that work really well for these LLMs, but that are somewhat domain specific, obviously, for the domain you trained it on. Yeah. And because everything we do to describe this process is again prompts, right? Like you instruct the LM to create a mutation by giving it a language instruction, you can apply the system on itself, and that makes it self-referential. So it's not just improving prompts, it's improving the way it's improving prompts at the same time.
Very interesting. I mean, I see one difference with PickBreeder, and that is that PickBreeder was farming creativity and agency from humans, and humans have access to all of this entropy and randomness everywhere. So I'm a huge fan of things like, chain of thought and self-verification and self-reflection and all this kind of stuff, but you always feel that there's something kind of static about it. Do you know what I mean?
I know what you mean, but I think it's fine for the following reason. And this goes back to David Deutsch. The moment you connect it to an empirical source of evidence, it's fine, right? Because it is grounded in that sense. That's my short answer to that. But I think at the same time, people are also underestimating the value of human-in-the-loop open-ended systems. Yeah. So I'm on board with that. I think if you think about like these amazing text-to-image and text-to video generation models. I mean, one thing is to have this kind of model be pre-trained, and you can say it's a great text-to-image generation model. But actually, if you think a little bit more about this, right, it's the humans, this kind of evolutionary system, right, of humans interacting with the system, finding interesting prompts, and then showing that online, and other people take then these prompts and make variations of them to generate even better images, right? There's this whole like open-ended system on top as well. It's basically PickBreeder on steroids with a generative AI model as well. And that's also why we were so excited about Genie, that we can potentially have generative environments, and at some point, I mean, not right now, but hopefully at some point in the future, might be able to share that with people to actually play with it and discover new environments that nobody has thought about.
Very cool. So where do you see this space going in the next few years?
I think we'll see a few things. One, I think we'll see more and more capable generative AI capabilities that really make us at some point confident that we can create really amazing simulations basically just with generative AI. And that will unlock a lot of potential for robotics, for entertainment, and so on. The other thing that we'll see is I think we'll see systems that make really amazing use of these humongous context windows and build basically open-ended self-improvement loops based on those. I think that's my two bets. I think that, and also the things that I'm personally quite excited about.
Amazing. And where can people find out more about your at DeepMind, but also at UCL DARK?
So we have, I think on Twitter you can find me, and also UCL DARK. And yeah, we have a webpage for UCL DARK as well. Yeah.
Amazing. Well, folks, we are keeping our powder dry a little bit because Tim's coming back on the podcast in a few months. We're going to film it in a big studio. So we're gonna time box this one. But Tim, it's honestly, it's an honor to have you on. I've wanted to have you on for years. Thank you so much for coming.
Thank you. It was amazing. Cheers.